Climate change is one of the greatest challenges facing modern society. It's an extremely complex issue and needs people with skills in many different areas. The research work undertaken at the University of Exeter's Cornwall campus really reflects this. We have experts working on the physical science of climate change who are trying to improve predictions into the future, people working on how we communicate and understand climate changes on the local level, and we have people working on preventing the worst impacts of climate change through work on transitioning our energy systems for a low carbon future.
We know that since the Industrial Revolution that Cornwall was a part of, that human-induced greenhouse gases have produced a 1.1 degrees Celsius warming in global air temperatures. Summertime Arctic sea ice has decreased by 40%, global mean sea level has risen by 20 centimetres, and extreme weather events are intensifying. But there are many things we still don't know yet. Understanding these complex interactions between these different components of the climate system is inherently complex. These complexities come about because of the feedback processes and mechanisms that operate between these different components of the climate system. For example, how the oceans might influence the atmosphere and how changes in sea ice dynamics might influence the surface of the oceans. My research focuses on developing a long-term understanding of how the climate and environment has changed over past centuries to millennia. I do this by looking at a variety of records derived from tree rings, long-lived marine bivalve mollusks or clams, and ice cores. By bringing these records together, we can get a really detailed understanding about how these different components of the climate system, such as the oceans, the atmosphere and the cryosphere, interact. Working with colleagues such as at the UK Met Office, we use these long-term records together with numerical climate models to better understand how climate has changed in the past to inform us about how the climate might change in the future.
Heritage sites are important. They can create a sense of connection to the past, but also inform things like our sense of place, identity and relationship to the landscape in the present. Many important heritage sites appear all along the coastline, and as such are in danger of being lost to coastal processes, which will only be exacerbated by the increasing effects of climate change. But loss isn't a wholly negative thing. It can lead to amazing discoveries and increased engagement with important sites. My work is not looking at how to save these sites, but how the inevitable loss of heritage assets on the coast can be understood and communicated both within the professional sector and out to the wider public.
I study the Antarctic ice sheet and how it might contribute to sea level rise in the future. I do this by looking at how the ice sheet has changed in the geological past during natural warm periods hundreds of thousands to millions of years ago. I work with colleagues from around the world, some of whom collect data showing how the ice sheet and sea level changed in the past. The data that they collect comes from various places, from ship-based drilling of ocean sediments that contain amazing records of past changes in ice volume, to ice cores that are drilled on Antarctica. My own work uses computer simulations to try and reproduce the changes that we see in the geological past. Ultimately, we're trying to improve these computer codes so that we have more faith in their ability to simulate changes in the future centuries under human-induced climate change.